we use send. We specify name of the destination process. Then we specify the message which we want to communicate. Then on the other side, in case of a receive instruction, we supposed to specify name of the sender process, name of the source process, along with we have to specify the message area. So message area is nothing but the location where the received message is to be stored. Here we have also seen that there are two naming methods, direct naming and indirect naming. So in case of direct naming, both the sender and receiver processes, they need to know each other. The meaning is that in case of send instruction, we need to specify name of the destination process, and in the destination process, that is in the receiver process, we need to specify name of the source process. So direct naming, it is a convention where the sender must know name of the receiver process and the receiver must know name of the sender process. That is what we call it as direct naming. But however, in case of indirect naming, the receiver process need not to know name of the sender process. Their sender must know name of the receiver, but however, the receiver process need not to know name of the sender process. That kind of convention we call it as indirect naming. In the indirect naming, in case of receive instruction, we won't specify name of the source process. Particularly in case of server kind of applications, we use indirect naming convention. And after that, we discussed about two important protocols which are used for message passing. We discussed about what is blocking protocol, and also we discussed about non-blocking protocol. So blocking protocol is one where the sender process will wait till delivery of the message. In other words, we can say that the sender process is blocked till delivery of that message to the destination. And remember, the blocking protocol, it guarantees the delivery of the message. Here, the instruction followed by send will be blocked till delivery of that message to the destination. Only when that message is delivered, the instructions followed by the send will be executed. But however, in case of non-blocking protocols, the sender is allowed to continue its execution without bothering about whether that message is delivered or not. So simply it will execute the send and will continue execution of the instructions followed by the send. So in this case, the operating system is going to use buffers. The operating system will store all the messages which are sent by the non-blocking protocol in the buffers, and these messages, they are delivered the moment when the corresponding receive instructions are executed. That is the concept of non-blocking protocol. So in today's class, we are going to look at the exceptional conditions. We are going to look at the exceptional conditions which may arise during execution of message passing. So here we have 4 exceptional conditions, and we will discuss what will be the solution for these. Okay, first we have the condition, the destination process. Try to understand, students, the destination process mentioned in the send does not exist. Many times it so happens that while writing the send instruction, you might have specified name of the destination process. Okay, what will happen if that destination process is not yet existing? If that process is not there in the system, that is one of the exceptional condition, right? Then in case of symmetric naming, the source process mentioned in the receive does not exist. Here, in case of receive also, you might have used name of the source process. You might have used the name of the sender process. There is every chance that that sender process may not exist. Or by mistake, you might be typing name of some other process which is not existing in case of a receive instruction. That is also one of the exceptional condition. And it may so happen that a send cannot be executed because the kernel has run out of buffer memory. Many times it so happens that the available buffers in the operating system may exhaust, and that time if the send is executed, what should be done? That is also one of the exceptional condition. And we have the fourth exceptional condition. No message exists for a process when it executes a receive statement. Students, the meaning is that you might have executed the receive statement. By that time, the send might not have executed. Because see, it is something like a parallel processing. We don't know which process will execute first. We don't know whether send will execute first or receive is executed first. It may so happen that a receive statement might have executed, but there may not be the corresponding send instruction. So these are the four exceptional conditions we have. So in all these cases, what should be the solution, right? Okay, first we discuss about the first condition. The destination process mentioned in this send does not exist. You might have written something like send pj, meaning that the message should be sent to the process pj. If pj is not existing, what can be done is simply we can terminate the process pi. If the pi is making any illegal process name, then no way we better to terminate that process. And in the symmetric name, if source process mentioned in the receive does not exist, then also there is no option. Most of the operating systems, they are going to terminate the process which execute the receive statement. Or a send cannot be executed. Third condition, send cannot be executed because the kernel has run out of buffer memory. So in such case, in third condition, the solution is we can wait. The process which is sending the message can wait till the availability of buffers. Because the buffer space is not available in the operating system, send may not get success in sending the message. Message cannot be sent successfully because of the out of buffer memory. In such case, we can lock the sender process till the buffer space is available in the operating system. Once that buffer space is available, the send process can continue its execution. And we have the fourth condition. No message exists for a process when it executes a receive statement. The meaning is that if receive is executed first, and if no message is existing, what we can do is, again we can hold that receiver process. We can block that receiver process till the message is available. Or otherwise, again, after waiting for some time, we can terminate the process pj. We can terminate the receiver process. Remember, students, these are the four exceptional conditions. What are the conditions? Very simple. The destination process may not exist in the send system call, or a source process may not exist in the receive system call, or a send cannot be executed because of non-availability of the buffer space in the operating system, or fourth condition is no message exists the moment when the receive statement is executed. Means if the receive is executed first, then again it is like exceptional condition. We need to provide some solution. Okay, students, remember these conditions. Okay, we have the next topic, that is mailbox. Students, don't think that this mailbox is like other mailbox. It's not like your email. It is entirely different. Here, mailbox, it can be defined as the repository of inter-process messages. The mailbox is a repository of inter-process messages. We use this mailbox for having communication between a set of processes. Okay, here if you look at the diagram, we have two processes. Just try to understand this diagram. We have a process pi and we have process pj. Process pi, it has created the mailbox, But don't think that this mailbox is like your email mailbox. It's the mailbox which is used to receive messages from the processes. Okay, we have a system called create mailbox, and in bracket we have used sample. Here sample is the name of the mailbox. Process PI, it is creating a mailbox with name sample, and here after that the process PI can execute receive statements to receive message into the mailbox sample, and we have a process PJ. The process PJ or even other processes, they can send the messages by using name of that mailbox. If the process PJ want to send the message, it is supposed to use a system called as send, the name of the mailbox, and it has to send the message which it want to send, right? So remember students, mailbox is a repository of inter-process messages. Here, if you look at this concept, we have some features of mailbox. The first feature is that a mailbox will have unique identity. So always, whenever you create a mailbox, you are supposed to use a unique name. It's something like variable name. It must be unique one. Then a mailbox will have owner, and only owner can receive the messages. The process which creates the mailbox is called as owner of that mailbox. And remember, only owner can receive the messages. No other processes can receive the messages from the mailbox. Okay. Here in this example, the process PI, it has created the mailbox with name sample, and now this process PI can be referred to as owner of the mailbox. Now you look at the diagram, students. Here we have a mailbox with name sample, which is created by the process PI. The process PI has created this mailbox. That's why we can say that process PI is owner of the mailbox sample. The mailbox sample, it has owner whose name is process PI. And within this mailbox, we can have set of buffers. We can have some memory locations where the received messages can be stored. And these processes, like here we have shown PJ, PK, and PL. They are the processes which can send messages. The processes which are allowed to send the message, they are referred to as users of the mailbox. So users of the mailbox, they are the processes which can send message to the mailbox. Here in this example, we can say that PI, it is owner of the mailbox sample, and PJ, PK, and PL, they are referred to as users of the mailbox sample. So remember students, here we have three important features. The first feature is that a mailbox must have unique identity. It must have unique name. Second one is a mailbox will have owner, and only owner can receive the messages. The process one which creates the mailbox is referred to as owner of the mailbox, and only owner process is allowed to receive messages. And any process which knows name of the mailbox can send the message. Any process which is knowing identity of the mailbox can send the messages. And these processes, they are called as users of the mailbox. So in this example, as we discussed, process PJ, PK, and PL, they are referred to as owners of the mailbox. And students, next we have advantages of mailbox. So basically these mailbox, they have two advantages. The first advantage is anonymity of the receiver. Here students, the sender process need not to know name of the receiver process. Try to understand the concept. Anonymity of the receiver means here the sender process need not to specify name of the receiver process. It need to know only name of the mailbox. Any process which is knowing name of the mailbox will be able to send the message. that process need not to know name of the owner. It need not to know name of the receiver process. Only thing is the sender process must know name of the mailbox. That's why we call this particular concept as anonymity of the receiver. Anonymity of the receiver means the sender process need not to know name of the receiver process. And we have the second advantage of mailbox, which is classification of messages. The mailbox allows to classify different messages. The idea is like this: for different kind of messages, we can create different mailboxes. It is possible to create multiple mailboxes, and each mailbox can receive a set of messages. So this permits classification of messages. Okay, here we have an example, students, for understanding the concept of classification of messages. Okay, this particular example is based on ticket reservation system. Okay, in railways we use, even in airport there exists ticket reservation system. Okay, that concept we discuss by using this example. Okay, students, assume that we have three mailboxes. In this example, we have three mailboxes. First name is inquire. Inquire is name of the mailbox. We have a second mailbox with name book, and we have a third mailbox with name cancel. So in this example, to classify different type of messages, we are going to use three different mailboxes. One is with name inquire, second one is with name book, and the third one is with name cancel. Okay, now we look at the code. If there is a booking request, if any process is making a request for ticket booking, then such requests, they can be sent to the mailbox whose name is inquire. The idea is that if any processes which are sending booking request, any process if it wishes to book the seats, such inquiry messages can be stored in a mailbox with name inquire. Then after inquiring, after getting the request for ticket booking, what we do is we are going to check whether the seats are available or not. Okay, if the seats are available, we can perform booking operation. We can perform ticket booking operation. So such information can be sent to a mailbox with name book. What I will do is I am going to check whether the seats are available for request made. If seats are available, such information or such messages, they can be sent to a mailbox with name book. And if successful, okay, first passenger has made the request, then we have checked whether the seats are available. If seats are available, the reservation for that particular seat is fixed. Okay. After that, if everything is successful, then we can inform the passenger. Otherwise, if there is a cancellation request, many times what happens is we might have booked the seats, but we may want to cancel the seats, right? Even such situation may be there. If such request arrives, if any request arrives for cancellation of the seats, booked seats, what we can do is such messages, they can be sent to a mailbox with name cancel. So in this example, what we want to understand is it is possible to create multiple mailboxes, and each mailbox can hold different types of messages. Inquire can hold booking requests. The book mailbox can hold information about the reservation of the seats, and the cancel mailbox, it can be utilized for storing or receiving cancellation requests. So this is how we can make use of mailbox. Students, again, this is one of the important topic from examination point of view. You can expect a question on mailbox. What is mailbox? What are the features and advantages of mailbox? You may get question like that, right? Okay, what is mailbox? So mailbox is a repository of inter-process messages. It is used for receiving multiple messages from different processes. What are the features we have? Three features you have to remember. A mailbox will have unique identity. The name of the mailbox must be a unique one. And second feature is the mailbox will have a owner and only owner can receive the messages. The process one which creates the mailbox is called as owner of that mailbox and only owner can receive the messages. And any other process which knows identity of that mailbox can send the message. And these processes which are sending messages to that mailbox, they are referred to as users of mailbox. Then two advantages we have. First one is anonymity of the receiver. The meaning is that here the sender process need not to know name of the receiver process. However, remember students, the sender process must know name of mailbox, but it need not to know name of the receiver process. Instead of knowing name of the receiver process, it must know name of the mailbox. And second advantage of mailbox is it is possible to create multiple mailboxes to store different type of messages. That is, the mailbox allows classification of messages. So this is all about mailbox. Okay, if you have any doubts, students, you can ask me. Any doubts, if you have, you can ask me. Any doubts?